In this video you are going to learn what combustion is, the difference between complete and incomplete combustion, the products of the two types of combustion, and the effects of the products of combustion. Combustion is burning, usually in air which is all around us, or oxygen. It's an exothermic reaction, which means it gives out heat. A fuel stores potential energy that can be released as heat when we burn the fuel. An example of a fuel is natural gas or methane. This is the fuel we burn to heat up our food. Methane, like other hydrocarbon fuels such as petrol, can undergo either complete or incomplete combustion. When methane undergoes complete combustion, that is in a plentiful supply of air, it produces carbon dioxide and water, as shown by the equation. CH4 gas plus 2O2 gas gives CO2 gas plus 2H2O gas. When methane undergoes incomplete combustion, that's in a limited supply of air, it produces either carbon monoxide and water or carbon and water, as shown by the equations. 2CH4 gas plus 3O2 gas gives 2CO gas plus 4H2O gas. CH4 gas plus O2 gas gives C solid plus 2H2O gas. Now the effects of the products of combustion. Water vapour, as we all know, is harmless. Carbon dioxide is a greenhouse gas and contributes to global warming. Carbon monoxide, however, is toxic. It's colourless, odourless, tasteless, and so is called the silent killer. Carbon monoxide is often produced by faulty gas appliances. That's why it's important to have your gas fires and boilers regularly serviced. Unburnt carbon is a particulate and is a pollutant in the air. So, to recap, combustion is burning, usually in air or oxygen. Complete combustion of hydrocarbons produces carbon dioxide and water. Incomplete combustion produces either carbon monoxide and water or carbon and water. And the products of combustion have various effects.
Let's talk about these 5 major types of chemical reactions. We'll look at examples of each and learn how to tell them apart so that you can look at a chemical reaction and classify it, figure out what type it is. The first combustion reactions. Combustion is basically a fancy word for burning. And when something burns, what happens is that a compound containing carbon and hydrogen, and sometimes oxygen, combines with oxygen gas to produce carbon dioxide and water. Here in my example, CH4, which is the chemical formula for methane, that's a type of natural gas, combines with oxygen and it forms carbon dioxide and water, H2O. Now, we can start with different things in a combustion reaction, and as it says here, the compound usually contains carbon and hydrogen. So here is another example of a combustion reaction. This one starts with C3H8, which is the chemical formula for propane, another type of natural gas. And just like with this reaction, we combine C3H8 with O2, and this gives us carbon dioxide and water. So these two reactions are essentially identical, except for the number of carbons and hydrogens in the compound that we start with. It turns out that a lot of things that we burn, like natural gas, diesel, gasoline, are really similar, and they only really differ in the number of carbons and hydrogens that are in the molecules that make them up. So combustion reactions for a wide variety of compounds look pretty similar. Now, as this definition says, sometimes we have oxygen in the compound that we're burning. Here is one example of a combustion reaction that has oxygen in it. This is the chemical formula for ethanol or ethyl alcohol, and you can see that just like these, it has lots of carbons and hydrogens, except it also has oxygen as well. But that's no big deal because it combusts just like the other two by combining with oxygen and making CO2 and H2O. So if we wanted to come up with a general way to write the formula for a combustion reaction, it might look a little bit like this. We start out with something that has carbon and hydrogen in it, and we can have different numbers of carbons and hydrogens. So that's why I put this X and Y here, because the number of carbons and hydrogens varies, and it doesn't really matter either. Sometimes the compound has oxygen in it, which is why I put the oxygen here in parentheses. We take this compound, it combines with oxygen, and it produces carbon dioxide and water. So this here is the generic general equation for a combustion reaction.